Hi everyone, and welcome to the CBRC Nikon A1 Confocal training. In this, we will go over turning on the microscope, setting up your slide, the microscope features, the Nikon Element software, acquiring an image, turning off the microscope, and rules we have for the confocal core in the department. So in this video, the machine is actually already on, but I will go through how to turn everything on. So the first box that goes on is this laser box. And here we have a key. When the microscope is off, the key will be in a 12 o'clock position. And in order to turn it on, you will turn it from 12 o'clock to 3 o'clock. This box 1 contains the lasers. We have 4 lasers on our microscope. We've got a 405 laser, which is commonly used for DAPI, a 488 laser, which is used for GFP, a 568 laser, which is used for RFP, and we have a 647 far red laser. Once you turn this box on, you will hear fans start to run, and that is a good thing. The second box that goes on is this master controller. What the master controller does is it connects the lasers to the microscope to the computer. It acts as a communication hub for the microscope. Once you've turned on this box 1, it's important to wait about 30 to 45 seconds before turning on this box 2. That is because it relies on the lasers being fully booted up before it can be turned on so that it can accurately connect the lasers to the computer and to the microscope. This box can be turned on from the side. You will see lights beginning to flash here, and they should all turn green. If you ever see any of these lights flashing amber for a prolonged period of time, that might mean that there was something wrong with the startup. You may also see an error message on Nikon Elements software, and if that happens, turn everything off except the lasers and wait about 2 to 3 minutes. After 2 to 3 minutes, you can go and turn on box 2 through 6, and that should start up correctly. The next thing that gets turned on is box number 3. Box number 3 is right here, and it contains the transmitted light power supply. After you turn on 3, you will turn on the fluorescence unit, and then lastly, you'll turn on the stage power supply. You'll notice here that these boxes are tilted at an angle. That's because these light tubes back here need to stay not bent. If you were to push these boxes against the back of the wall, it would bend the light tubes and prevent light from passing through. The last thing that gets turned on is the microscope itself. It is a button back here. It is a little bit tricky to see, so I would suggest for your first few times actually using a flashlight on your phone to help you locate it. Finally, the last thing you'll turn on is the computer. The computer is sometimes left on and it is sometimes off. If it's on or if it's off, you can just switch it on here. So next I will show you how to set up your slide on the microscope. We've got 2 stages. We have a TIZ drive and a piezo drive. The difference between these 2 stages is that the piezo drive uses an external motor, which you can see here, and it actually has a cord attached to it, whereas the TIZ drive uses the internal motor of the microscope to change the Z position. There's not a huge amount of difference between the 2, but some people have a preference to one or the other. The only thing here is it is important to select on the Nikon Element software which stage you're using so that it can accurately move the Z position. Here I'm going to show you how to mount a slide. So in this I am using an oil objective. Here I'm using the 40x oil objective. So I'm just putting a very, very small drop of oil onto the objective. You don't need much oil, it's just to create an immersion barrier between your sample and the objective. This is an inverted confocal microscope, so I'm flipping my slide upside down so that the cover slip is nearest to the objective. So now I'm going to go on to some microscope features. So these are more of the buttons that are on the scope that you can use. So when you first come in, you will see that there's this front panel, and this tells you a couple of things about your sample. It first tells you which objective you're using, and it also tells you the Z position. When you first turn on the microscope, the default Z position is around 500 micrometers. This is very far down, and so in order to bring your sample into focus, you need to bring the objective up. Normally, most people's samples come into focus between 2,000 micrometers and 2,500 micrometers. There is some slight variation depending on your sample, but this is a good place to start in terms of finding your sample. This is the joystick pad, and this allows you to move the stage left, right, up, and down. You can change the speed at which the stage is moving by twisting the top knob of the joystick. You can also change the Z position by this side roller, and you can again change the speed of that using this button on the top right-hand side. Shown here is the right-hand side of the microscope. Down here is the refocus button, which drops down the objective. Here puts it back into focus. This button switches between the filter cubes, and this changes the speed of the Z mover. Now I will go through the Nikon Elements software. So to open Nikon Elements, you can click this icon here. This will prompt you to log in. In your second training, you will make a user profile, and this will allow you to log in to your settings, and it'll keep the same interface as from when you last imaged, and it'll keep the same settings from when you last imaged as well. During your second training, the Confocal Core Coordinator will help you set up the interface so that it looks similar to this. Once you've placed your sample onto the stage, you can click iPort, and while you're looking through the iPort, you can bring your sample into focus, and you can also use fluorescence to observe your staining. Here, you don't have to worry about laser light passing through your sample because there's an interlock on that prevents any laser light from going through the eyepiece for your safety. Once you have your sample visualized through the eyepiece as you want it, you can put it onto scan. So scan takes a live feed image of your sample with the lasers. So the interlock will come on and you will no longer be able to look through the eyeport, and instead it will pull up the image with the lasers. While it's scanning, you can adjust the gain and the laser power to optimize the visualization and the settings of your sample for image acquisition. There are two ways of acquiring an image. You can click capture, or you can do ND acquisition. So when you click capture, that takes a screenshot of how your sample is scanning with the live feed image, and it is slightly lower resolution, and it does not save automatically. So we suggest people use the ND acquisition. However, if you want just a quick image, you can use capture. Just make sure to save it separately. When you click Find, that turns on the high speed, low resolution settings if you just want to quickly go through your sample. Fortunately, we find that our system is fast enough to where most people don't use this, but it is available to you if you choose to. Here we have two types of scanning. We have Galvano and resonance scanning. Galvano is a high resolution scanning, and resonant is low resolution, high speed scanning. With Galvano, although it is slower speed, it provides higher resolution, and this is what most people in our department use. AG is for auto gain, and here we get into the direction of the scan. You can do unidirectional scan or bidirectional scan. Most people have it on unidirectional scan. So here we get on to the speed and the size of the image. There's a trade-off between speed and size to where if you make your sample really, really slow, that actually exposes your sample to laser light for longer, and you run the risk of bleaching your sample. And the same trade-off for size, if you make the size of the image really, really large, it's exposing your sample to laser light for longer. And again, you can run the risk of bleaching your image or bleaching your sample. So most people in the department have found the optimal balance to be 1/2 or 1/4 frames per second and a size of 1024. And this gives really nice high resolution images, and images of 1024 size are considered publication quality. Down here, we get into line averaging. So here you get into channel series and setup. So you can arrange the channels in any way you want. Most people have this in a sequential form to where you get separate images for separate channels. But if you needed to do something more technical, you could adjust those settings. Down here, we get into pinhole. So the pinhole is really vital for the confocal. And it's what makes the confocal a confocal. And what that means is that it allows you to focus the light on a very specific slice of your sample, and without getting signal interference from above and below that plane. So for that reason, you need to have the pinhole very small so that that laser light is focused in a very small region. If you were to make the pinhole too large, you essentially turn the confocal into a fluorescence microscope, and that defeats its purpose. So, and the optimal pinhole is around 1 or 1 area unit, and that is small and preserves the confocality of the microscope. To open image settings, you can click this icon, and in this, you can change any of the colors of the channels to how you want. So here I'm just changing the DAPI channel to a purple. Color on the confocal is entirely artificial and can be assigned as you wish. You can also use this portion to decide if you want to use the transmitted detector or not. So the transmitted detector gives you a bright field image, and for that bright field image to appear, you need to have the transmitted detector in, as shown here. But the other thing you need to be aware of is you need to make sure that the neck of the microscope is down. The neck of the microscope is not required for imaging with the confocal, but it is required to get this transmitted detector. The other thing you can do in this is select which channels you'd like to use, but this can also be done here. We ask that people not adjust the numbers associated with the different channels because those are optimized for the system. So now we can get on to adjusting the brightness and the laser power for each laser. And HV is the gain, which is equivalent to just the brightness. Gain is entirely artificial, so it does not impact your sample in any way. And this is a really great place to start when you're beginning to optimize visualizing your sample. What I suggest you do while you're kind of adjusting the gain, increasing or decreasing brightness, is to actually scroll through the Z position of your sample to ensure that the brightness you're seeing is accurate and not just in the wrong plane. So once you've kind of established the gain, you can then move on to laser power and adjust accordingly. If you're putting up your gain super high, I'd actually recommend to put up the laser power slightly, but it's just striking a balance between laser power and gain to optimize the visualization of your sample to where it's accurate to what you should see. You can also adjust offset. However, offset can also be adjusted afterwards, and with an image analysis software like ImageJ or Fiji, because we ask that people not use this as a analysis software in terms of using up time that other people could be using the scope to take images. So it's really important just to strike the balance between gain and laser power. Laser power does impact your sample, and if you increase the laser power too high, you can bleach your sample. Furthermore, our lasers have a finite lifespan, so we want to keep the laser power on the lower side. However, if your sample requires you to increase the laser power slightly, that is okay too. Generally, you don't want to put the laser power above 6. Otherwise, there might be a staining issue or an issue with the plane of your sample. Down here, we get into the TI pad. So everything on the TI pad can actually be done physically on the microscope. However, there's some features that people find easier to use on the computer and some features that people find easier to use on the microscope. So one thing that people find easier on the computer is deciding which objective to use. We have 5 objectives, and this 6th position is currently empty. We have a 10x air, a 20x air, a 20x oil, a 40x oil, and a 60x oil. It is really, really important that you never get oil on the air objectives. If oil gets on the air objectives, it will actually degrade the lens and cause them to break, and it's very expensive to repair. For that reason, we ask that people go into their imaging session knowing which objectives they're going to use and decide if they're going to stick with air or stick with oil, because you can't go between the two. Down here, you get into light path. We have 2 light paths. We've got E100 and L100. So E100 tells you what path the light is taking, and E100 is the path of the eyepiece, meaning that light is going through the eye port, and there will be no laser light being used. L100 means that the interlock is on, so there's no light coming through the eyepiece because the lasers are on, and this is telling you that the light is taking the path of the lasers. This should change automatically when you click between eye port and scan, but if it doesn't and the lasers aren't coming on or you can't see anything through the eye port, you might manually need to click it. Here we get into changing the Z position. This is one of the things that people actually find easier to do on the microscope with the Z position knob on the right-hand side of the joystick pad. Here we get onto filter cubes. So filter cubes are what you would click through when you're visualizing your sample through the eye port to see different channels of fluorescence. So we've got a bright field, a blue, a green, a red, and an orange. 647 is not visible to the human eye, which is why we can't have a filter cube for it. So once you click scan, the filter cube will go into this empty position and laser light will start to pass through. If the sample ever looks weird when you're scanning, it might be because the filter cube is still on. So just check that, and you can always click it to this blank position. But like I said, this should occur automatically. So here we get onto the A1 scan area. And what this does is it allows you to zoom into a specific part of your sample image without changing the objective. And you can do this by shrinking this box, right-clicking to confirm a new scan area. This feature is really nice if you want to take both zoomed out image and a zoomed in image without changing the objective and losing your plane of focus. It's also just faster than changing the objective. So the last thing that I will briefly go through is directing an image to a specific file. So we ask that everybody save their images in a folder titled with their name within a folder called Confocal's users. And the reason we do this is because this is not a storage software, and we will frequently go through and delete images. You should regularly be offloading your images, and we will give 2 weeks notice before we delete anything. So here I'm just showing you how the folder looks, where we have everybody's names and then my folder and then the folders within my folder from the different imaging sessions. Once you decide which folder to direct your images into, the images will save automatically to that folder once you run an image. Another nice thing about the Nikon Element software is that it actually allows you to, it'll help you pre-title your images. So if you were to name something wildtype 001 and put that number, a number at the end, the next image you take will actually be wildtype 002. If you change samples, obviously you need to change the name. So before I go through acquiring an images, I will take you through an example of how you can scan your images, adjust the laser settings and the brightness before you actually take the full image. So here I'm just looking at my sample through the eye port, and you can see that I'm adjusting the Z position here. And once I have it in a Z position that I like, I will click scan. So scan brings up this live feed image that I was telling you about. And from here, I can adjust the brightness of the individual channels. So here I've just increased the gain or the brightness of the DAPI channel. One thing you'll notice is that the transmitted detector region is currently black, and that is because I do not have the neck of the microscope down. So once I put the neck of the microscope down, you will see this bright field image start to appear. In order to get this merged image, I clicked this button here. And in order to split the channels into multiple different boxes, I have this button selected. Right now, I just moved the stage slightly using this button here. So what I'm showing you here is looking at pixel saturation. You can tell the computer to show which pixels are saturated with this here, and I have mine selected to cyan. It is important to strike a balance between saturated pixels and unsaturated pixels to where you get a holistic viewpoint of your sample. So here you can see in this red channel, I've got these selected, a very small region of points that are saturated, so that would be considered good. And there I just changed the color of the pixel saturation. So now I will show you the different types of image acquisition that can be done. So here you can take a time lapse of your sample where you can tell the confocal to image every 10 minutes with specific lasers, and all of that can be adjusted in the advanced setup of this. The next type of image that can be taken is a single XY plane image. And to do that, you will just click Add a Point, and then you can add multiple points, and the confocal will go between each of those points and take an image. This gives you a single XY plane. So here is taking a Z-stack. There are Z-stacks are the most common types of images acquired on a confocal because, like I mentioned earlier, the beauty of the confocal is it allows you to get a single plane resolution of your sample. So taking a Z-stack can give you actually a 3D rendering of your. So here is taking a Z-stack. There are Z-stacks are the most common types of images acquired on a confocal because, like I mentioned earlier, the beauty of the confocal is it allows you to get a single plane resolution of your sample. So taking a Z-stack can give you actually a 3D rendering of your sample through multiple planes. There are 3 different types of Z-stacks you can take. It's most common for people to define the top and the bottom of your sample, and then the confocal will image between those 2 points. Here you can set a midpoint and then a range. So there will be the same amount of distance above that midpoint and the same amount of distance below. You can also do that asymmetrically with this button here. If you choose to use the top and bottom define, just make sure when you're going between samples, you click Reset to clear the old Z positions. With this, you can also define the step size. The smaller the step, the more images you'll have in a small area. The larger the Z steps, the actual steps, the more distance there will be between each. Lastly, it is really important, like I mentioned earlier, to tell the computer what stage you're using. So we've got the TIZ drive and the piezo drive. So with this drop down here, you can define which stage you're using so that it knows which motor to use to change the Z position. Lastly, you can do a large image stitch where you can stitch together multiple regions of your sample, and all of those settings can be adjusted here, and more fine settings can be created or adjusted in this advanced settings bar. So in this example, I am going to define the top and the bottom of my sample. So here I am. I've just used the knob on the side of the joystick to go to the top of my sample, and there I'm going to select top, and now I'm going to scroll to the bottom of my sample. And select bottom. So here I've got 42 steps. So because I'm using 5 channels, this will take a little bit of time. So it's going to take about 5 minutes. So now the image has been fully acquired, and you can scroll through the different Z positions of your of your Z-stack. So to close everything out, you can just click this X up here, and it will ask you if you want to end the imaging session. And assuming all of your things have been saved accurately, you can go ahead and click OK. That will close down the software. So now I will go through turning off the microscope and cleaning the microscope. So it is really important, if you've used oil, to clean off the objectives after using them. And remember, if you use multiple oil objectives, to clean all of the ones you've used. So what I just did there was removing my slide, and now I'm going to remove the stage. The first wipe I do is just with a dry lens wipe to remove a majority of the oil. Next, I will go through and put a solution called Sparkle, which is a specialized lens cleaner, onto a lens wipe, and then wipe down the lens to remove any other oil residue. The last thing I do is to dry the lens to remove any leftover residue. So here I'm turning everything off in the reverse order. So 6, and then 5, 4, box 3, box 2, and box 1. When turning off the lasers, turn it to the 12 o'clock position. Lastly, I'll go over the confocal rules. We don't allow people to use the confocal for more than 4 hours in one day. If you need to image for longer than 4 hours, we ask that you do the additional hours outside of the normal 9 to 5 working day. This is to allow everyone in the department, or all of the users, to have equal access to the confocal. If there's someone booked less than 1 hour after you, make sure you leave the microscope on. We do our scheduling and the bookings through lab archives, and you will receive an invite after your second training to either be granted permission for the confocal or to be invited to lab archives. If you are the last user of the day, make sure the confocal is not left on overnight, meaning that if there's someone that is on the confocal after you, you should confirm with them that they will be attending their appointment. If you need to cancel your reservation, try to do so in far advance as possible so that either other people can book or that nobody leaves the microscope on for you. Make sure you fill out the sign-in sheet for accountability and for billing. We do not have the biosafety certification for live human cells, so you cannot image live human cells on the microscope. You can image fixed human cells and live mice cells, but not live human cells. That requires a special biosafety certification. Using the scope is $35 an hour. You are billed for the first hour in its entirety, and then after that in 30-minute increments. In terms of saving data, we don't allow people to save to hard drives. Hard drives can introduce viruses to the Nikon software, and that's expensive and difficult to replace. So we request that people only save to Dropbox and the server. If you ever have any questions or concerns while imaging, please contact anyone in the White Lab, and ideally the Confocal Core coordinator. Thank you.